We're now ready to discuss 3 ways of changing up the structure of your data. I expect that most of the time, if you're working with relational data, you shouldn't have to do any restructuring. Typically, you will have each observation or unique instance of a class as the rows, and attributes of a class will be the columns. Sometimes you will come into contact with data that isn't normalized this way, and you'll want to be able to get it back into shape. Alternatively, you may want to aggregate the data in a particular way, thus departing from typical data structure. So being familiar with these different data structuring methods will ensure that you can wrangle your data into any shape you need it to be in. The first is data transposing. This is the simplest. You're simply switching the orientation of the data. What were once columns are now rows, and vice versa. Next comes pivoting the data. You typically do this when you want to summarize the data. You pick a column to be your pivot, and for this pivot, all the unique values that the column takes on will become all new columns of the table. The rest of the data will then be aggregated. This is often described as taking a table from a tall format to a wide format. Last, we'll look at unpivoting. Here, if you can imagine, we're doing something analogous to the opposite of pivoting. We're taking related columns and turning them into a single column of values. In other words, this transforms the data from a wide format to a tall one. I'll be honest, these can be pretty tricky for students the first time they come across these concepts. So I'm going to do a visual demonstration of each, and then we'll try these out with data. Like I said, transposing is the easiest to grasp. Suppose we've got some data oriented like this. We're summarizing values across counties as the columns and months as rows. If we want to report this data, it tends to be better to present time variables going from left to right. So if we transpose the data, the counties will now be the unique rows with months as columns. This is transposing. Let's try pivoting now. We've got individual sales observations. To keep things simple, we only sell 2 products, A and B. There may be different prices and quantities, so the sales amounts might vary, but it's in a normal data structure right now. Each sale of a product is a row with 3 attributes about our sales as columns. We can pivot this data to summarize sales of products for each date. We would designate the product column as our pivot. So now the values that product can take on will now become the columns of the new table. So to repeat this again, we choose product as our pivot. And what values do we see that product column taking on? A and B. So in our new table, we have 2 columns, one for A and one for B. Now the values of the new table show the aggregated sales for any given date product combination. For example, there were 2 sales of product A on January 1st, and the sum of these 2 sales is what is now reported in the top left corner of the new table. Lastly, unpivoting. I grabbed some data from the World Bank. I've used it previously in my research. To practice data structuring, let's connect to the relevant file. Get data from an Excel workbook, and we'll select data structuring. We've got both a sheet and a table. Usually these are identical. One thing I'm noticing is the sheet version does not have column headers. They call it column 1, 2, 3, whereas the table has promoted these. Let's select table 1 and transform this data. My first step is always renaming queries. I'll call this GDP data. And this is data from the World Bank, each country's GDP for a given year. The World Bank likes to list countries as rows and years as the columns. But to do a time series analysis, I typically want to have a unique observation for each country year. I'm going to want to unpivot these columns. So starting with 2015, I'll select it. I'm going to hold down my Shift key and then click through 2019 to select all 5 columns. I'll go up to Transform and find the Unpivot Columns button. And now every country in this sample has 5 observations, GDP for every country year. We also notice the default options to name these columns is attribute and value. If I wanted to go back, we know we could just click the X over here. But instead of doing that, I want to show you how we can get back to the same place by pivoting this data now. So I'll select the attribute we want to pivot around. We're going to pivot this column, and the prompt now says, use the names in column attribute to create new columns. Well, this attribute, these are the years. We want a column for every year, and then it just asks us, and what are the values? I'll click the drop down. In this case, it's called value, but this is the GDP. Those are the unique data points or values that we want to aggregate around. I'll click OK, and it looks exactly like it was before. And just to demonstrate this, and go ahead and do this with me, go ahead and now click the X twice. Finally, I want to show you what happens when we transpose data in Power Query. Again, transposing is change the orientation, making the rows the columns and the columns the rows. There's a transpose button up here right next to transform, and when I click it, we now see that each country has become a column in this data set. One thing we note, we've lost the years now. The column headers that we used to have now vanished, and we're left with these plain nondescript column headers. So I'm going to go back. Let's hit the X next to transpose table. I'm going to go up to this use first row as headers, but this time I'll click the drop down and say use headers as first row. We're demoding these. So now when I transpose, we've preserved country name and all of these years. And of course, if we wanted to fix this up, we could now use the first row as headers. Ultimately, I don't expect you to need to restructure data all that often in your professional life. But when those occasions do arise, you want to be confident and know what are your various options to doing so.